How about you?
There's a small bit of portion remaining in coordination compound. And after that, we are going to start organic chemistry. Okay. So we're doing the isomers and specifically stereoisomers of octahedral complexes. In octahedral complexes, we have seen the monodentate ligand case. So all of these cases that we have seen right now, these are the cases in which the ligand, it is a monodentate ligand, that means it is coordinating with the metal atom with only one position. नेक्स्ट केस जो है इसमें आपका है bidentate ligands. And in this all of these cases इसमें जो है यहाँ पे this is important. M A3B3 वाला जो case है, this is quite important because in this case we have fat and mer type of isomers. So fat mer are typically important. Okay, so now for monodentate. Sorry, bidentate. Bidentate ligand. Okay, so in octahedral complexes, now we are going to have a bidentate ligand, and bidentate ligand की different cases देंगे. So first of all, we are going to make the same patterns जो हम लोगों ने पहले यहाँ पे बनाया था. That means we will have the complex. Table बनाना पड़ेगा ना. We'll have complex. Then after complex, we look at the GIs, the geometrical isomers, and for geometrical isomers, we check the ligands that are opposite. Opposite to each other. If we have a ligand A, what is opposite to A? Then B, then what is opposite to B? After GI, we look at the optical isomers. And for each optical isomer, there will be a pair of enantiomers, enantiomeric pairs, and then the total number of stereoisomers. The total number of stereoisomers. Guys, any idea that what will be the first case for bidentate ligand? Bidentate ligand में सबसे पहला केस जो बनेगा वो कौन सा होगा?
MA3.
MAA3 है ना? Very good. I think you meant the same thing, right? MAA. This is a bidentate ligand. That means metal is coordinating with A atom and A atom also, and this is 3 times. Correct? Yes or no, please tell me.
Yes, sir.
Okay. Now, in this case, obviously, first of all, we are going to look at the GIs. So GI में देखने का क्या ही फायदा होगा? अब सबसे पहली बात तो, if you remember bidentate ligands are always at 90 degrees. This is something that we saw in the square-planar structure also. The square-planar case, we wrote that with bidentate ligand does not. Bidentate ligands will never be at 180. They will be always at 90 degrees. तो हमारे पास जो bidentate ligand होंगे, they will be always at 90 degrees. कभी भी 180 में नहीं हो सकते. So I will write like this. AA, both of these are in 90 degrees, and it is coordinating with one A here like this, another A here like this. So no matter what case you take, a capital A will always be opposite to a capital A only, because we don't have any other ligand. And no matter how much you try to change it, there will be no geometrical isomer, because A will be always opposite to A in this particular case. So geometrical isomers will be 0. For stereoisomers, in this case, for optical isomers, in this case, we have to actually look at the compound. See, metal atom. Now, please also understand that these 2 bonds, these are inside the plane. And These two bonds, these are outside the group. Okay. Now at 90 degrees, we are trying to keep things at 90 degrees. So the only case we can have is AA like this. Then we will have AA like this. So there is a bond between A and A also, right? That is why it is a bidentate ligand and a chelating ligand also. Okay. This is one of the orientation that you can have. This is the one of the orientation that you can have. अच्छा, अब दूसरा एक जो orientation हो सकता है, which will be like this. Copy will be better. To see. Correct है, yes or no? Please tell me, guys. बताइए.
Yes, sir.
ठीक है, अब ध्यान सुनिए. For optical isomers, what should we check? Geometrical isomers, you have to check the ligands opposite to each other. For optical isomers, there are two things that we check. What are those two things? Tell me, guys. अरे पढ़ो पढ़ो जल्दी पढ़ो जल्दी पढ़ो जल्दी पढ़िए आप लोग. What are the two things that we have to check for optical isomers? अगर ऑप्टिकल आइसोमर किसी का होगा तो क्या नहीं होना चाहिए? Last to last class, I think we have discussed this. For geometrical isomers, check ligands on opposite to each other, and for optical isomers, we have to check what? क्या check करते हैं? किसी के नोट्स में नहीं है? सफिया, इरम, अरसलान. पढ़िए तो. You are not going to read them, how you will understand.
सर.
हाँ बताएं.
हाँ यस सर है मेरे पास.
बोलिए.
to check optical हाँ सेंटर ऑफ सिमेट्री और प्लेन ऑफ सिमेट्री
होना चाहिए. ऑप्टिकल आइसोमर अगर है तो होना चाहिए, नहीं होना चाहिए? नहीं होना चाहिए, नहीं होना चाहिए, है ना. तो सेंटर ऑफ सिमेट्री या प्लेन ऑफ सिमेट्री नहीं होता. पहले बात देखते हैं सेंटर ऑफ सिमेट्री है या नहीं है. ठीक है. इफ यू आर गोइंग टू लुक, मतलब ऊपर से अगर आप देखिएगा ना, यहाँ पे आपको नजर आएगा एम है. इसके ऊपर आप गए तो आपको ए मिला, इसके नीचे गए तो आपको क्या मिला? ए मिला. इसके राइट साइड इधर लोअर साइड गए तो आपको ए मिला, उधर भी गए तो ए मिला, इधर भी गए तो ए मिला, इधर भी गए तो ए. ठीक है ना. सो ऊपर से देखिएगा तो यू विल सी दैट इट इज हैविंग सेंटर ऑफ सिमेट्री. But let us analyze the structure even more. Let us analyze the structure even more. Okay. Now please see, ध्यान से देखिएगा. This is my metal. I bent like this. So this is a bond, right, between A and A. Correct है? This is a bond. Yes or no? अरे बोलो.
Yes sir.
है ना? And if I go this way, do I see any bond?
No
नहीं,
sir.
यहाँ तो bond नहीं है. So that means center of symmetry is not present, even though at the first instance you will see that there is, you may think that there is a center of symmetry. But if you look closely, if you go in this direction, you see a bond, but opposite to that direction, you are not seeing a bond. That means center of symmetry is not present. Now we have to look at the plane of symmetry. Whether plane of symmetry is present or not present. Whether plane of symmetry is present or not present. Now for this, सबसे पहले देखिए, what are the planes that we can take? What are the planes that we can take? तो यहाँ पे देखिए, फर्स्ट प्लेन तो आप ये ले सकते हैं. आपने इस पूरे मॉलिक्यूल को ऐसे करके काट दिया. You cut the molecule in this particular fashion. Now, obviously, you are obviously not going to have any plane of symmetry, because on the right side, यहाँ पे आपके पास bond है. On the left side here, you don't have any bond. So on the right side, there is a bond falling down. On the left side, there is no bond falling down. That is why that this cannot be the plane of symmetry. This cannot be the plane of symmetry. Is there any other plane of symmetry that is possible? So you can check one more. That is going to be this plane of symmetry. If you cut all of these ligands, then will there be plane of symmetry? क्या ख्याल है? Try to think about it. Will there be plane of symmetry? See, in the first instance, here also you will think that yes, sir, there will be plane of symmetry now. Why? Because ऊपर आपके पास एक ये देखिए, all of these 4A's, ये सारे A तो कट जाएंगे, उनका तो आपको ध्यान नहीं रखना है. All of those 4A will cut. Whatever is in the plane, it will be fine. ऊपर में बचा आपका that is A, और नीचे भी आपके पास क्या बचा A. So you will say, sir, there is a plane of symmetry, no? Because यहाँ पे A, हम बोलेंगे नहीं, because आप बोलिएगा फिर सर अच्छा ठीक है, बॉन्ड की अगर आप बात करें तो बॉन्ड ऊपर भी एक बॉन्ड है, नीचे भी एक बॉन्ड है. Can all of you guys see that? Yes or no? Please tell me. For an untrained eye, it will look like there is a plane of symmetry, right? This is a plane of symmetry, yes or no? बोलो भाई, हाँ ना तो कुछ आवाज आना चाहिए. Yes. थोड़ा ध्यान से देखते हैं. Now we are going to talk about a bit in detail about this particular bond. So this bond that is in blue, this is going inside the plane or outside the plane?
Outside the plane.
नहीं, inside जाना. देखिए, this is the plane. ये आपका plane हो गया, है ना? One A is on the plane, और ये जो दूसरा A है, this is inside the plane. So bond is going from the plane to inside the plane. Correct, guys?
Oh, okay, sir. Yes, sir.
Can you see that? But what is happening with this particular bond? Here we have A atom. Here we have A atom. Now in this case, the bond it is going from the plane to the outside of the plane. Can you see that?
Yes, sir.
That is why, even though it seems like this is having a plane of symmetry, but no. Above what is happening, a bond is falling down inside the plane. Below what is happening, a bond is falling down outside the plane. So it cannot be the plane of symmetry, right? Equally गिरना चाहिए ना हर जगह, same चीज है, at the same side. So that is not happening. That is why this particular structure is not having any plane of symmetry. And if it is not having center of symmetry, if it is not having plane of symmetry, then we can say what? We can say that it is going to have a optical isomer. इसका यहाँ पे एक optical isomer होगा. It will have, sorry, दो optical isomers होंगे. My bad. There will be two optical isomers and one enantiomeric pair. So these two are enantiomeric pairs. Okay. Now a very common example that you will see in the exams and the textbook is cobalt En whole price. En is ethylene diamine, 3 positive or 2 positive. So this is, it has two isomers, enantiomeric pairs. Okay. The total number of stereoisomers is going to be. So this is an important case. इसको आपको ध्यान रखना है. Octahedral MAA3 bidentate. ठीक है. Now let us see. ये सबको समझ में आया नहीं आया बताएं. कृष्णप्रिया, सफिया and इरम. अरसलान तो होता है आंसरिंग.
Yes, sir.
Yes, इरम. Iram, are you not there in the class? आया आपको समझ में? सफिया, what about you? Yes, Safia.
Yes, sir, understood.
Understood ना पक्का? Okay. Next is when you have a metal AA2 and then there is a monodentate ligand A2. Okay. So I am erasing this stuff right now because we have to bother. अब देखिए यहाँ पे. There can be only two cases here. आप A के अपोजिट रख लीजिए A को, A के अपोजिट रख लीजिए आप A को, and both of these are at 90 degrees, and then you can have small A opposite to small. Correct, guys? Yes or no? Please tell me.
Yes, sir.
Yes, sir.
Another case that you can have is the small A is opposite to the large A, that means the bidentate ligand के साथ है, and then you have another small A that is opposite to the larger A, and then you are going to have A. Okay. I will also make both of these structures very easy to make. Don't worry. We have A at 90 degree, capital A at 90 degree. So this is the case that we have drawn in the terms of what is opposite to each other. Now for this structure, you can have the same thing, M with 6 bonds. And if I talk about the metal atoms, then in this case here we are having A, and also we are having another A. That's fine. We cannot have this type of structure. We can have A should be together, right? Yeah, I think this is fine, right? A के push में have larger A के push में have larger A. Now what are the bidentate ligands? उसको हम बता देते हैं बस. So these two are together at 90 degree. These two are together at 90 degree. है ना? So these are the two structures. अब यहीं पे आपके पास we have a name for this. This is again once more it is important that when you are having MAA whole twice and then A2. This form is known as the cis form. Trans हो जाएगा ना, because same things are opposite to each other. This is trans form and this is the cis form. This is trans, where the bidentate ligand is opposite to each other and the monodentate ligand is also opposite to each other. And the other case is going to be the cis form. Clear है guys? Yes or no? ठीक है. Now, obviously, this is going to be a geometrical isomer. तो आपके पास ये दो geometrical isomer मिल गए, एक cis form और एक कौन सा form, और एक आपके पास मिला ट्रांसफॉर्म. अच्छा, इस केस में देखिए, जो ट्रांसफॉर्म है, इट इज गोइंग टू हैव ऑल काइंड ऑफ सिमेट्री. इसमें सेंटर ऑफ सिमेट्री भी आपको नजर आएगा. देखिए आप ना बॉन्ड्स के तरीके से देख लीजिए, और यू कैन आल्सो सी इन टर्म्स ऑफ द लिगेंड्स दैट ए के ऊपर ए, नीचे भी ए, साइड में बॉन्ड, इधर भी साइड में बॉन्ड. दिस साइड यू हैव कैपिटल ए, दिस साइड यू हैव कैपिटल ए, है ना. सो यू कैन सी दैट देयर इज अ प्लेन ऑफ सिमेट्री हियर. नाउ इवन इफ सेंटर ऑफ सिमेट्री इज प्रेजेंट, अगर सेंटर ऑफ सिमेट्री हो गया तो ऑप्टिकल आइसोमर हो ही नहीं सकता है. ठीक है ना. You don't have to always look for plane of symmetry. You start with center of symmetry. If the center of symmetry is present, you don't have to look for the plane of symmetry. So once the center of symmetry is present, we can ignore that. Okay, fine. इसका ऑप्टिकल आइसोमर नहीं होगा. आगे चलते हैं. Now for this particular case, obviously you can see that center of symmetry तो present नहीं है. Why? Because metal के ऊपर यहाँ पे A है, and below it we have a capital A. So small a or capital A है, तो obviously center of symmetry. Now we are going to look at the plane of symmetry. But you can also see that plane of symmetry भी यहाँ पे हो ही नहीं सकता है. If you can take some planes, for example, you take this plane. Then this side you are having what you are having. This side you are having A. वो सारी चीजें ठीक है, but this side you are having a bond. Here you are not having any bond. The plane of symmetry is not possible for the cis structure, और उसमें center of symmetry भी नहीं है. Now this particular cis structure will have one optical isomer. तो ये cis structure और एक optical isomer, कितने optical isomer हो गए? दो. एनांटियोमेरिक पेयर जो बनेगा वो एक बनेगा. नाउ स्टीरियो आइसोमर्स की बात होगी तो ध्यान दीजिएगा, इस ज्योमेट्रिकल जीआई में भी सिस है और वही सेम सिस यहाँ ऑप्टिकल आइसोमर में भी काउंट हो रहा है. तो 4 मत लिख दीजिएगा, 3 लिखिएगा. क्या बात समझ में आ रही है आपको? व्हाई डज 3 यस और नो प्लीज टेल मी. नहीं,
Yes, sir.
बात समझ में आई? अरसलान इरम, तो जल्दी हो गया क्या? आराम से समझाएं. अरसलान इरम सत्या.
Yes, sir.
फिर से
हाँ.
ऐसे आप समझिए, आपके पास है ए, बी और सी. ठीक है. ए एंड बी आर कजन्स. ठीक है. बी और सी भी कजन है. तो कितने कजन हो गए अरसलान? टेल मी. दो कजन. दो कजन अगर है तो कितने भाई हो गए? If there are 2 cousins, then how many brothers we have having? तीनों अगर लड़कियां मान लीजिए तो
Sir,
दो
we
अगर पूछा.
have
हाँ नहीं, ऐसे ऐसे 2 कजन बोलेंगे तो लगेगा 4 है कितने, लेकिन इस पर्टिकुलर केस में बात समझ में आ रही है आपको?
हाँ सर, थोड़ी बहुत
समझ में आया ना. तो ये समझ लीजिए, ए और बी जो है आपका, ये दोनों एक दूसरे के जीआई है, ज्योमेट्रिकल आइसोमर. बी और सी एक दूसरे का क्या है? ऑप्टिकल आइसोमर. टोटल नंबर ऑफ आइसोमर्स कितने होंगे?
3.
समझ में आया? 3 क्यों होगा?
Okay, sir.
है ना? ठीक है, तो B जो है इट इज ज्योमेट्रिकल आइसोमर ऑफ A एंड इट इज आल्सो ऑप्टिकल आइसोमर ऑफ C. इस वजह से यहाँ वाला ऐसे लगता है 2 2 4 होने चाहिए, लेकिन 2 + 2 3 भी हो सकता है ना. 2 + 2 इज नाउ कितना? 2 + 2 कितना होगा?
3.
3 होगा, है ना. मैं वाले सर आपको मार देंगे. चलिए खैर आगे बढ़ते हैं. अब देखिए इसमें ना आगे आपको ना केसेस निकाल जा रहे हैं जो इंपॉर्टेंट होगा वहां उसमें आपको नोट कर देंगे. दिस इज फॉर दिस एग्जांपल इज दिस इज आल्सो इंपॉर्टेंट बिकॉज़ यहाँ पे आपके पास क्या है, सिस और ट्रांस बन जा रहा है. व्हेनेवर यू हैव सिस एंड ट्रांस दे कैन गिव यू अ कॉम्प्लेक्स. बोलेंगे इसका सिस और ट्रांस बना के बताइए, वो आपको आना चाहिए. देन वी हैव m. सिमिलर केस एक आता है MGA2 and then we have AB. So here we have geometrical isomers. Geometrical isomers यहाँ पे होते हैं 2. Same बिल्कुल optical isomers यहाँ पे होगा आपके पास 2. An isomeric pair will be 1 and the stereoisomers will be 3. Same case बन जाएगा, बस यहाँ पे B लगा दीजिए, यहाँ पे B लगा दीजिए. Got it guys? Listen please tell me. अब यहाँ बोलेगा सर एक सेकंड. अगर यहाँ पे B आ गया तब तो सेंटर ऑफ सिमेट्री नहीं होगा. Yes, obviously बात है. Here we are getting A, in the below we are getting B. So obviously there will be no center of symmetry. But अगर आप इस plane of symmetry को ले, if you take this particular plane, then you will have a plane of symmetry. A के उधर आधा A गिरा, इधर आधा A, आधा B, आधा B. This side you are getting A and this side also you are getting A. That is why there will be a plane of symmetry in the trans isomer. ठीक है, that is why you are not having a optical isomers of the trans form. सिर्फ और सिर्फ सिस फॉर्म का ऑप्टिकल आइसोमर है. Next we are going to look at what are we having M. A2 का AB हो गया, then we can have AA. In this case first of all हमारे पास होगा A4. ठीक है. In MA4 we are not going to have anything. कुछ भी आपके पास नहीं हो सकता. Why? Let us see. How many bidentate ligands are we having here? Tell me guys. How many bidentate ligands we are having in the fourth case? कितने bidentate ligands हैं? बोलो भाई. भाई audible? देखिए. In the first case, how many bidentate ligands are there? Hello. भाई audible? कृष्णा भाई आसवान सब क्या?
Yes, sir.
How many bidentate ligands are we having in the first case?
2.
ये है ना यार, ये है ना bidentate ligand. A bidentate है ना.
Oh,
क्यों लिखा है यार?
Oh,
second
okay,
वाले
sir.
में, second
2.
वाले में, third वाले में,
2.
and fourth वाले में that you see in this case.
1.
ठीक है. And bidentate ligands are going to be at what degree? हमेशा कितने डिग्री में रहेगा? 180 या 90? 90. हमेशा 90 डिग्री में. ठीक है ना. So we are having one bidentate ligand. That is why we cannot take this case. A opposite to A, it will never be present. Why? Because bidentate ligand are never at 180 degree. They are always at 90 degree. Opposite तो कभी हो ही नहीं सकता. So you are going to have A always like this. ठीक है. अब A के opposite में क्या रहेगा? A what are the other things remaining now? Because the position of AA is fixed. 90 डिग्री में ही रहेगा. So we have one A like this, and then remaining we have AA. इसके अलावा you cannot have any other case. That is why there will be zero geometrical isomer. And once we are having zero geometrical isomers, और हम लोगों ने एक चीज पढ़ी थी अगर आपको याद हो, if two same ligands are present on the opposite side, if two same ligands are present in the opposite side, then plane of symmetry is present after this cases में. तो obviously यहाँ पे optical isomers कितना हो जाएगा? 0 हो जाएगा. And isomeric pair 0, stereoisomers will be 0. हाँ, let us move on to the other case. यहाँ पे आपके पास आएगा M, AA, A3B. Now in A3B you can see that एक बार आप क्या कर सकते हैं, you have AA, एक बार दोनों A के अपोजिट में A रख दीजिए, and then you can have A के अपोजिट में B. Another case that you can have is A के अपोजिट में B, A के अपोजिट में A, and then A के अपोजिट में B, and then A के opposite में A. ठीक है, so there will be two cases. In one case, capital A के opposite में small a. In the other case, we'll have capital A के opposite में small a. Can you see that as well, guys? बात समझ में आ रही है?
Yes, sir.
ठीक है, इसके अलावा you cannot have any other case. So once B is opposite to small a, and in the other case B is opposite to capital A. Okay, after that, so here we are going to have two geometrical isomers, and in this case also will not have any optical isomers because there are two same ligands. A3 है ना, जब तक A2 रहेगा, then two same ligands are opposite to each other. In all of these cases you can see ना, यहाँ पे भी आपके पास what do we have? इस केस में देख लीजिए, यहाँ पे AA और A opposite to each other है. Pair of ligands are opposite to each other and they are same pair opposite है तब भी, और यहाँ पे आपके पास जो ligand ही opposite है तब भी आपके पास you will not have any geometrical isomers. ये चीज पता नहीं आप लोगों ने रिवाइज किया नहीं की है, but I think we have written this somewhere. When two pairs of ligands opposite to each other are same, then POS is present. Pair भी अगर आपके पास opposite to each other same हुआ तब भी वहाँ पे POS होगा. तो optical isomers will be 0. They will be 0. Stereo isomers will also be 0. My bad. Stereo isomers 0 नहीं होगा. Stereo isomers 2 हो जाएंगे ना, because geometrical isomers present. दोनों नहीं करेंगे हम. After this, we are going to have a case in which we are having M, E, E. A2, B2. A2 and B2. अब इस केस में आप क्या कर सकते हैं? A के अपोजिट, देखिए A तो ऐसे रहेगा. एक बार A के अपोजिट में आपने A को रख दिया और B के बीच में बॉन्ड आ गया. एक बार आपने A के अपोजिट में B को रख दिया और A के अपोजिट में A आ गया. और एक बार आप क्या कर सकते हैं, A के अपोजिट में B को रख दीजिए और एक कैपिटल के अपोजिट में A, दूसरे कैपिटल के अपोजिट में B. ठीक है, इसके अलावा आपके पास और कोई केस नहीं बन पाएगा. Here we are having how much? कितना हो गया? 3 geometrical isomers. Correct, guys? Now, in the 3 geometrical isomers, if you look at the first two, B is opposite to B. That means there are two same ligands opposite to each other at one point. Then here you will be having POS. A opposite to A, two same ligands opposite to each other at 180 degrees. So again, POS. इस particular case में you are not having any of the conditions for POS or COS. किसी कोई भी condition यहाँ पे follow नहीं हो रहा भाई, because A is opposite to B, ठीक है, and the pair of ligand AA is opposite to AB, है ना? The pair of ligands are also not same. So this particular isomer will have, ध्यान से देखिएगा, this isomer will have a optical isomer. इस टू के अंदर जो टू है उसमें से एक ऑलरेडी काउंटेड है 3. ठीक है, दैट इज व्हाई यू विल हैव एक तो एनाटोमिक पेयर हो जाएगा एंड टोटल नंबर ऑफ सी आइसोमर्स विल बी 4. आई होप अर्सलान यू अंडरस्टूड व्हाई 4 नॉट 5, है ना? यस अर्सलान?
Yes, sir.
Yes. After this we are going to have a case in which we are having M, A, and we can have A2, B. You know, all of these cases ना आप इसको अच्छे से एक बार कर लीजिएगा घर में, अदरवाइज आप भूल जाइएगा. लाइक तो टेबल रखना पड़ेगा आपको, है ना? M, A, 2, B, C. A is going to be like this always. एक बार आपने क्या किया, A के पोजीशन में A के पोजीशन में A and B के पोजीशन में C. Then what we can have, A is always going to be like this at 90 degrees, and in this case we can have A के पोजीशन में क्या करते हैं, BC कर देते हैं, and then A के पोजीशन में we'll have A. After that, what we can do, there can be another case in which we are having A is going to be like this only, and BC here we are having, we can have A के पोजीशन में A, and then A के opposite में B, and then we will have A के opposite में C. Same thing we can do. A के opposite में we can have A के opposite में we can have C, and then we can have A के opposite में B. I think there are no other cases which are possible for this particular case. If you look at the opposite structure, then you can find only these 4 isomers which are possible geometric isomers. Now let us look at the optical isomers. So in the first case, pairs of ligands are same, opposite to each other. ये दोनों और ये दोनों क्या है? Opposite ligands are what? Same to each other. That is why this will have a POS. Here we are having AA. Two same ligands opposite to each other. That is why there will be POS. Okay. In this case, there is no POS or no COS also. COS तो होगा ही नहीं because we are having different kinds of ligands. Here, the two conditions for POS is not satisfied. First, neither pairs of ligands are opposite to each other, nor same ligands are opposite to each other. Okay. So here you will not have any POS. यहाँ पे POS नहीं होगा. That's it. This will have optical isomer. This will also have an optical isomer. Now, in this case, we can say that because we have 4 geometrical isomers, and there will be 4 optical isomers also. But how many enantiomeric pair? 2 enantiomeric pairs. Stereoisomers कितने हो जाएंगे बताइए? How many stereoisomers will be present? Guys, tell me. How many stereoisomers? क्या हो गया?
6.
6. Very good. है ना? 4 4 8 नहीं, क्योंकि 2 ऑलरेडी काउंटेड है जीआई में. It will be 6. And last case जो आपके पास आता है, that is M AA with a bidentate ligand, and we are having A B C D. इसमें याद कर लीजिए, बहुत आसान है. Here you are going to have 6 geometrical isomers. All of these 6 geometrical isomers will have optical isomers. तो आपके पास optical isomers जो हो जाएंगे, optical isomers आपके पास 6 6 दूनी 12. 12 optical isomers, and the pairs कितने हो जाएंगे? You will have 6 pairs, and the total number of stereoisomers will be 12. ठीक है, you can write all of these cases, है ना? A, ठीक है. A के अपोजिट में आपने एक बार रखा A, इधर रखा आपने B, फिर आपने रखा C, फिर आपने रखा D. ठीक है, मतलब CD की बात में छोड़ दी. You can have BC, फिर उसके बाद आपने रखा CD. ठीक है, फिर उसके बाद आपने लगा DA. Okay, A, B, B, C, C, D, D. So these are what? These are the different. ये 4 अलग अलग हो. ठीक है, अब B, C के बाद क्या बचा? A, B बचा. A, B का आ जाएगा. You have right now you are having how much? 6. Is there any other possible? You can have AC. A के अपोजिट में A के अपोजिट में C. What else you can have? AC हो सकता है PD. Then you can have PD. तो ये है 6 आपके पास. बात समझ में आ गई? ये समझ में आएगी नहीं आया? सलाम सब किया है, इसका पिया. You guys got this?
Yes, sir.
Yes, sir.
So there is no other case that you can have now. 1, 2, 3, 4, 5, 6. Now, like if you are having capital A opposite to B, capital A opposite to A, then the remaining pair A or D हो गया. बचा क्या? B, C. तो B and C will be opposite to each other. Okay, this is fixed. The bidentate ligand, we have the fixed position at 90 degrees always. Okay, actually, please copy this down. Copy this table down. Raise your hand once you are done. Raise your hand once you're done writing, okay? So yeah, just waiting for you now.
Done, sir.
So with this, coordination compound is completed. Now we are going to start with organic chemistry. First chapter in the organic chemistry is haloalkane and haloalkane. start this chapter with a question because obviously basics of organic chemistry आपको आना जरूरी है. So please write a question. Classify the following as aliphatic or aromatic. Aliphatic or aromatic. Primary. Secondary or tertiary. And then saturated or unsaturated. Okay. First structure that we're having is this. All of you guys understood the question? Hey, Bulu bhai.
Yes, sir. Now, seven structures. You have to classify whether it is aliphatic or aromatic. You have to classify whether it is primary, secondary, tertiary, whether it is saturated or unsaturated. Okay. Just send the answers on my WhatsApp. Okay. I'm giving you guys 5, 6 minutes. Typically. Guys, 2 more minutes. Achha, raise your hand if you have no idea what this question is. Krishna Priya, Arslan, and Satya. Raise your hand if you have no idea what this question is. Okay, all of you know what this question is. Okay. 2 more minutes and we will send the answers on WhatsApp. Okay, I've got your answer. Your first one, correct. Degree will not be there because degree of carbon is not possible for all the compounds. And सारे compound में जरूरी नहीं there will be a degree of carbon. Okay, but still I understand where you are coming from. है ना? ठीक है, चलो. Okay. Second one is also correct, I guess. Let me see. Made a wrong structure, made a different structure, but I mean, according to your structure, it's fine. Then you have third one, correct. Yeah, and then the fourth one. Correct. Very good. What about बस ये आपका जो sixth वाला सही नहीं है. Krishna Priya, sixth one is not right. Also the sixth one and fifth one. With primary, secondary, tertiary, you have messed up there.
The sixth question.
Sixth question, fourth question also.
Okay.
What about others, Aslan and Satya?
Sir, I'm actually
Wait,
not
sir,
having
send it.
phone, so can I write in the chat?
You can't send the photo.
Sorry?
Can't send me on WhatsApp.
Actually, I don't have my phone, that's why.
Acha, ठीक है, you can write in the chat.
I'll send on
1,
chat.
2, 3. Yeah, send on the chat. But make sure you're sending it to Salim, okay? And number it like 1, 2, 3, and so on.
Okay, sir.
Salam, send it now.
Yes, sir.
correctly. I can see that. Satya, I'm waiting for your answer. Can you send me whatever you have done till now? जो भी किया आपने उसको please भेज दीजिए.
Yes, one second.
Yeah, so see, the first structure that we are having here, that is this structure here, it is aliphatic. And 1 degree, we cannot say whether it is secondary because there is no important carbon atom substituent यहाँ पे नहीं है. That is why we cannot really say it is 2 degree, 1 degree कुछ भी. But yeah, we can say that it is unsaturated. But I understand the second degree atom because we are terming this particular carbon atom as an important carbon atom. This can get to 2 carbon atoms. Yeah, double bonded wala. Okay. Next we are having second structure. आपने aromatic बोला है. It is not aromatic. Aromatic will have a benzene ring, and otherwise it is going to be aliphatic. So this is aliphatic and it is what saturated. This is aromatic and it is unsaturated. Now, when you are having benzene ring, you can say that it is a 2 degree carbon atom. This is a 2 degree carbon because it is connected to 2 carbon atoms like this. But generally, that is not very important. In this case, fourth structure mein it becomes important that it is aliphatic. It is secondary because this carbon atom is connected to 2 more carbon atoms, directly connected to. This will be 2 degree, and it is also what it is saturated. This structure, it is aliphatic. If it is not aromatic, it is going to be aliphatic. Aliphatic, and then we have this particular carbon atom. It is connected to only 1 carbon directly. एक carbon से directly bonded. That's why it is going to be 1 degree. क्या लिखा है आपने आंसर में से fifth वाले में? Second. हाँ, I understand. ये होती है mistake इसी वजह से नहीं सारे सवाल कराते हैं ठीक है ना? Okay, so this is what this is not 2 degree. It is 1 degree. I hope you can see that. Yes or no? Please tell me, guys. All of you can see that. That it is
Yes,
1 degree. है ना? Okay. Similarly, you guys have done a mistake here that you have classified this. This is also 1 degree because this carbon is connected directly to 1 carbon atom only. Okay, so this is 1 degree. Otherwise, everything else is correct. Aliphatic and it is also saturated compound. This is aromatic. This is unsaturated, and this you can say it is 2 degree, but it doesn't matter that. But I hope all of you understood. Yes or no, please, Sanni? Thoda idea lag gaya. Saturated, unsaturated, aliphatic, aromatic, वगैरह.
yes,
If you have
sir.
doubt in any one of these questions, please let me know. नहीं ना, चलिए ठीक. सबसे पहले we'll start with quick classification of haloalkane halogene. That is on the number of halogen atoms. ठीक है? So right, classifications. We can do many types of classification on different bases. But the first classification is classification of haloalkane halogene, and the basis is the number of halogen atoms. Okay, so right, classification of haloalkane halogene. What is the basis? The basis of number of halogen atoms. So mainly इनको 3 different इसमें classify किया जाता है. When you have one halogen atom, when you have two halogen atoms. And when you have three halogen atoms. When you have one halogen atom, we call it, if it is haloalkane, we call it mono halo. So let me type this, I think it will be saving space. So क्या बोलते हैं, if you have one halogen atom on a compound, in a compound, then we call it mono haloalkane. If it is haloarene, then we call it mono haloarene. Okay, so I hope you know what is haloalkane and haloarene. When it is having a benzene ring, it is haloarene. Right, it is arene. If it is not having benzene ring, then वो alkane हो जाता है. ठीक है. So for two haloalkane, you are going to call it di haloalkane, and then you are going to call this one di haloarene. For three halogen atoms, for when you are having three halogen atoms, क्या बोलते हैं simply tri haloalkane and tri haloarene. ठीक है. बहुत आसान सा है. सवाल भी लिख लीजिए तो ज्यादा आसान आप लोग को एक बार समझ में आ जाएगा. राइट अ क्वेश्चन. Classify the following on the basis of number of halogen atoms. Number of halogen atoms. ठीक है. The first structure that you are having. ध्यान दीजिएगा, if it is benzene तब वो haloarene, if it is not benzene then वो haloalkane रहेगा. ठीक है ना. Second structure. सवाल समझ में आ रहा है ना, ऊपर से तो नहीं जा रहा आप लोगों के. बोलिए. हाँ, असलान, कृष्णप्रिया एंड सफिया.
Yes, sir.
समझ में आ रहा है ना. So, 5 सवाल आपके पास, जल्दी जल्दी हम करके भेजिए. I think 4 minutes will be enough. कुछ तो आप लोगों ने कर लिया हो. Yes, Krishna Priya, correct. Very good. Arsalan, waiting for your answer. Yes, Safiya, very good, correct.
Yes, sir. One second.
Arsalan, जल्दी भेजिए.
Yes, sir. I'll just send.
Let's see. So this one here, the first one is. अरे आपने क्या लिखा भाई, ऐसे कैसे समझ में आएगा? अरसलान, इतना तो टाइम दिया आपको, आप क्या कर रहे थे? बिल्कुल इतना गंदे तरीके से लिखा, कुछ समझ ही नहीं आ रहा. हालोअल्केन लिखा है या हालोअरेन लिखा है? फर्स्ट इज मोनो डाई ट्राई ट्राई डाई. ठीक है, तब इतना तो सही है. हालोअल्केन हालोअरेन समझ नहीं आ रहा. सो दिस इज mono haloalkane and this is dihaloarene. This is trihaloalkane. This is trihaloalkane. This is dihaloalkane. ठीक है. I hope इसमें आप लोगों ने गलती नहीं की होगी. Krishna Priya and Safiya, your answers are perfectly fine. I don't know about Aslam, by the way. मैं समझ ही नहीं आ रहा क्या लिखा असलम. Moving on. Next, we have to do classification in our class. We have to do classification of the different types of haloalkane. And in haloalkane, हम लोग basically जो देखने वाले हैं, we are going to look at the monohaloalkanes only. Classification of monohaloalkanes. Next. सबसे पहले ना आप लोग एक नोट लिख दीजिए रिगार्डिंग हाइब्रिडाइजेशन, तो आपको याद रहना चाहिए. इज लाइक if a carbon atom has number one double bond, then it is known as sp2 hybridization or sp2 hybrid. Or you can call it as that it is sp2 hybridization. After sp2 carbon, if it is having two double bonds, then it is sp hybridized. If it is having one triple bond, then also it is sp hybridized. Or when it is not having
any double bond or triple bond. Right, like this, no double or triple bonds. Then it is sp3 hybridized. Okay. So monohaloalkanes से जो classification है ना, is on the basis of the carbon atom in which in which the halogen is connected. We will write here monohaloalkanes. When the carbon atom that is connected to halogen atom, when it is sp3 hybridized, इसके classification हम लोग देखेंगे. And when the carbon atom that is connected to halogen atom, it is sp2 hybridized. ठीक है, इसके classification हम लोग देखेंगे. So in the first case, जो आपके पास sp3 hybridized में, इनको generally बोला जाता है these are alkyl halides. Call them alkyl halides. Now, in alkyl halides, we can have further classification. Number one classification, that is primary. Primary alkyl halide. Okay, na? AH degree, this is alkyl halide, or we call it 1 degree alkyl halide. For example, if you have CH3, CH2, Cl. Okay, so this carbon atom, the carbon atom that is connected to halogen, it is 1 degree carbon. है ना? या फिर आपके पास एक जो हमने केस दिया था आपको. So this carbon atom is also what 1 degree carbon atom. ये 1 degree है, this is 1 degree. So the halogen connected to carbon atom, that carbon atom is what it is, 1 degree. इसी तरह से you can have secondary haloalkane halide या फिर haloalkane, or we call it 2 degree. 2 degree में क्या होगा आपके पास, you can have Br आपके पास second degree carbon में है, or it will be something like this. Okay, so these are example of secondary alkyl halide. And the C case in this alkyl halide will be the tertiary alkyl halide. Tertiary alkyl halides. इनको क्या बोलते हैं 3 degree. तो 3 degree में आपके पास जो केस आएगा CH3 carbon, CH3, CH3. The carbon that is connected to 3 other carbon atoms is further connected to what? It is further connected to the halogen atom. ये तो सिंपल सा केस हो गया बिल्कुल. इसके बाद जो थोड़ा कॉम्प्लिकेटेड केस है which is going to be important and new also for you guys to learn, that is allylic carbon या फिर allylic alkyl halides. Allylic alkyl halide, इसमें क्या होता है, please understand. You will have halogen atom, it will be connected to a carbon atom. This carbon atom will be further connected to another carbon atom. ठीक है, क्या होगा यहाँ पे, halogen atom connected to sp3, but this sp3 is connected to sp2 carbon atom. Is that clear? Yes or no? Please tell me, guys. बोलो भाई. Halogen atom connected to sp3 carbon, which is further connected to sp2 carbon atom. ठीक है, क्या बोला हमने? Please write this as halogen atom. Halogen connected to sp3 carbon, which is further connected to sp2 carbon. बात समझ में आई है? चलो प्लीज सुनिए गाइस. अर्सलान कृष्ण प्रिया, देखिए एग्जांपल देखिए. फॉर एग्जांपल, you have halogen atom here, this carbon is sp3 और यहाँ पे आपने डबल बॉन्ड लगा दिया, तो ये कार्बन क्या हो गया, sp2 हो गया. This carbon here it is sp3, but this carbon is now what, it is sp2. But this type of compound is known as allylic alkyl halide. Now, or example देखिए, cyclic case में you can have example something like this. You have double bond here, और यहाँ पे आपके पास X atom. So halogen is connected to carbon. This carbon is sp3. क्योंकि कोई डबल बॉन्ड ट्रिपल बॉन्ड नहीं है, सारे के सारे सिंगल बॉन्ड्स है. This sp3 is further connected to sp2. Got it, guys? Yes or no? Please tell me.
Yes, sir.
इसके बाद जो आपके पास थर्ड केस आता है, दिस इज ऑल्सो वेरी इंपॉर्टेंट, तो आपको याद रखना, ये नई चीजें है ना, यू हैव नॉट लर्नड अबाउट दीज थिंग्स. बेंजाइलिक एलाइल, बेंजाइलिक अल्काइल, बेंजाइलिक अल्काइल एलाइल. बेंजाइलिक कार्बन इन जनरल क्या होता है? बेंजाइलिक कार्बन इस केस में क्या होगा? You will have halogen atom which is connected to sp3 carbon. This sp3 carbon will be further connected to benzene ring. ठीक है, further connected to benzene ring. बात समझ में आ रही है? ऐसा नहीं गई? बोलो.
Yes, sir.
ठीक है, ठीक है, तो लिख देते हैं यहाँ पे. Further connected to benzene ring. ठीक है, चलिए अब इधर आते हैं हम. ये तीन केसेस आपको याद रखने किसके लिए? और भी haloalkane, जहाँ पे halogen atom it is directly connected to sp3. Now when you are having halogen atom that is directly connected to sp2, तो यहाँ पे आपके पास सिर्फ और सिर्फ दो केसेस है, विनाइलिक एंड दूसरा होता है अराइलिक. तो राइट, फर्स्ट नंबर क्या है आपके पास? वन नंबर इज vinylic alkyl halide. In vinylic alkyl halide, what happens? The halogen atom is connected to carbon, which is sp2. Simple सी बात. Halogen atom directly connected to sp2 carbon. Simple. बस इसके आगे पीछे कुछ नहीं देखना आप. So this is a vinylic carbon directly connected to what? Directly connected to. So लिख देते हैं. Then we will write example. Connected to sp2 carbon. बस और कुछ आपको देखना है. ठीक है. एग्जाम्पल, एक एग्जाम्पल ये हो गया आपके पास कि you have halogen like this. Like this. Correct, guys? Halogen atom, you can see halogen atom is connected to carbon. This carbon is what? Is having a double bond. If there is a carbon atom having a double bond, this is going to be sp2. Similar thing is here. Carbon having double bond. दूसरा case जो है, that is known as arylic alkyl halide. Arylic. इसका हम लोग haloarene भी बोलते हैं. Also known as haloarene. इसमें क्या होता है? The halogen atom that is directly connected to the benzene. Yes, directly connected to what? It's directly connected to benzene. I think I don't know whether you have written this note or not. Please write this note. Raise your hand if you are already done. अगर आपने पहले से ही लिख लिया तो you can raise hand. You have raised hand. इसने नहीं लिखा है. Someone has not written. Satya, you are writing. Please write it. Satya, raise your hand once you're done. Satya has also done. So now you can write regarding monohaloalkanes. इसमें एक you can write यहाँ पे बेंजाइलिक तक लिखना है आपको. ठीक है ना? So first of all you will write regarding allylic, vinylic ये लिख लीजिए. फिर आगे आप चलिए इतना लिखिए कम से कम. Write till here. Write till here and then raise your hand once you're done.
You guys are done. The right allylic and benzylic. Raise your hand if you're done writing till benzylic also. Just waiting for Arsalan now.